Hey, OChemsters, this is Mrs. Vanderlei bringing you more OChemstar video. So we're in section 3.3 talking about, again, double and triple bonds. Maybe you want to jot down and triple bonds because we're going to include ethyne in this. And we should be getting out our model kits, but if this is not feasible, then we'll do the next best thing and kind of wing it, all right? So I actually have some pictures of ethane and ethene and ethyne, all right? And we're going to answer some questions about it, okay? So you ready? Here are my pictures. Here is my ethane, my ethene, and my ethyne. So take a look right here. How many atoms are attached to this carbon? 1, 2, 3, 4. How many attached to this carbon? 1, 2, 3. And how many attached to this carbon? 1, 2. So let's write that down. So we have, ready? We had 4 carbons attached here, 3 carbons attached here, and 2 carbons attached here, okay? What about rotation? Let's check this out. So do you think right here, can this single bond rotate? And the answer is yes. We learned about that with the alkanes. They can rotate around. But what about here? And this is really important, by the way. Can these carbons rotate around each other? Nope, that pi bond keeps it in place. All right, what about here? Can these rotate around each other? The answer is no. The 2 pi bonds keep that in place. So let's write that down. So yes, you can rotate alkanes. No, you can't rotate alkenes. And no, you can't rotate alkynes, okay? So let's look at the geometry of these, all right? Do you recognize this? What did we say 4 was? Wasn't that tetrahedral? Yup. This is trigonal planar, and this is linear. Well, let's fill that out. So we have tetrahedral, so I'll just kind of abbreviate it. Tetrahedral, this is kind of harder to write. And you can finish off writing it. So what if I write TP? What does that mean? Not toilet paper. Trigonal planar. You write that out, okay? It's not trigonal pyramidal, it's trigonal planar. Here, I'll put that right there. And this was linear. All right. Oh, there we go. That says liner. Sorry, it should be linear. Angle, bond angle, this is going to be your 109.7. This is your 120. And this is your 180. Okay. Finally, bond length. Well, let's look at this. Which bond looks the longest? Just look at these pictures. Which one is the longest bond? The single bond does. The double bond is like pulling it to each other, and the triple bond pulls it in even further. So this is your, oops, wrong way. There we go. So this is your longest, this is your medium, and this is your shortest. Okay. So let's continue on in 3.4 and let's review the pi bond. So we've already talked about this before when we did our intro. And when we had a double bond, if you recall, the hybridization was actually sp2. And that is what, in a sense, those orbitals overlap to make the first sigma bond. And notice we have a leftover p bond. It's not part of the orbitals that were hybridized, okay? So it says the 2s and 2p orbitals are combined to form 3 hybrid sp2 orbitals, leaving, this important, 1 electron still in the p orbital, all right? So it says, note, you now have 3 equal sp2 orbitals and 1 p orbital left over, okay? And that's what this is. This is that leftover p orbital. So this is like looking at it from the side. This is going up and down, and this is looking at it from the top. You can't really see that this part right here is that p orbital that you didn't use, okay? So let's go to the next page. So what happens when these overlap? So here is we're going to form, first of all, this first sigma bond. See that? Here's your sigma bond. And as they're being drawn closer to each other, then this right here, these are your unused p orbitals overlap, all right, and that is your double bond, okay? So you start off with the sigma here, and here is your pi bond. So it says what happened to the other sp2 orbitals, meaning right here and right here. You got 4 unused right now sp2 orbitals. Well, they're going to use for other bonding, namely probably your hydrogens, all right? So that's where your hydrogens are going to jump into. So if you want to look at what's called ethylene, all right, that's your ethene, if you will, consists of this one sp2 carbon-carbon sigma bond. That's when it comes together like this. That's your sigma bond. See that? And then you have these hydrogens. You see you have 4 hydrogens in this. This is your other sigma bond of hydrogen and your sp2 of your carbon. And then this blue area is your is your pi bond. And what is it that I want you to know about this, okay? Coming into our next section, you need to understand that this pi bond does not allow for rotation. Okay, so maybe write that down along here. The pi bond, the way it is formed, that overlap, does not allow for rotation. If you do want that rotation, you need to break this pi bond, and pi bonds are weaker than the sigma, so if you're going to add stress to the system, the pi bond is what's going to break first, okay? And then once it breaks, all right, then it can rotate. That sigma bond does rotate, okay? So this is leading into section 3.5 and 3.6. So we'll do that another time. Don't wait to be great. We'll see you next time. Bye-bye.